But so start us off by just explaining, Harpreet, what machine vision is.
Yeah. So when you think of like just traditional image classification, right? You'll have, let's say, some image, you present that to your neural network, and then you'll obtain a class label and some probability kind of associated with that prediction, right? So you got one image in, one class label out, and that's great when the thing that you're interested in is maybe characterizing the majority of that image space, or it's like
Mhm.
the most prominent thing in that image. Um, but object detection takes that one step further because it's not only telling you what is in the image, like the class label, but also where in the image that thing is, right? And it's telling you that via a bounding box. So you get bounding box coordinates. So to object detection, you'll input an image. Video is still just a series of images, but you input an image and you obtain multiple bounding boxes and class labels as the output. So just kind of, you know, at the core of this, any object detection algorithm kind of follows a similar pattern, right? The input is the image that you want to detect objects in, and then you'll get an output of a list of bounding boxes, which are the XY coordinates for each object in the image, the class label, and then some probability score associated with what the network thinks that thing is.
Nice, very cool. So the classic machine vision task. So 10 years ago, machine vision researchers, the state of the art was mostly focused on classifying the whole image, like you were just describing. So, famous architectures like AlexNet, released in 2012, was working on the ImageNet large scale visual recognition competition data set. And they were in that competition, you're just trying to get the whole image right. So, like, the image would be primarily of a cat or a dog or a plane or whatever. And you'd want the algorithm to be able to identify that. With object detection that you're describing, it's this more specialized task where there could be lots of things going on. There could be a cat playing with a dog, and so you have to be able to first put a bounding box, like you said, which is just a rectangle of any dimensions. That so it could end up being that in the image is just a big cat face, and then the bounding box would just be like basically like the whole image, or it could be that there's like just a cat in the corner and there's nothing else. Like, I don't know, the whole rest of the image is just like plain brown. There's nothing going on. So then you'd have a little bounding box in the corner where the kitten is, or you could have a bunch of things going on: a bus and a horse and a cat, and so you have these rectangular bounding boxes all over the image, and then you're tasked with correctly identifying what's in that bounding box. So it's a much more complicated task because you're breaking down the big image into a bunch of smaller images and then classifying each of those objects that you find, that you detect in the bounding
Yeah.
boxes. There's also, to maybe help people kind of understand how there are like different kinds of machine vision tasks. There's also image segmentation, which is
Hmm.
instead of being
Pixel.
bounding boxes, it's pixel by pixel. So every
Yeah.
single pixel in the image gets classified as a particular category. And so, yeah, like different kinds of approaches. I think image segmentation, like maybe that's better when you have a relatively constrained set of classes where like maybe in like a self-driving car application, you're like, okay, we need to be able to identify like pedestrians, cars, road. And so you have kind of this relatively finite set of uh, classes that you'd want to be able to bucket the pixels into. But
Hmm.
I think that object detection, and I'm not an expert in this stuff, you might know more than me, but with object detection, you could have, I mean, with modern deep learning algorithms, it's probably almost limitless. Like you could have a crazy number of possible objects. You might even be able to do, whoa. I just thought of this, right. Like I don't spend much time thinking about this, Harpreet, but you could use object detection to find where the bounding boxes are, and then you could use like a clip style algorithm to just, you could literally describe anything. Like then you have an infinite number of classes. Like,
Hmm.
and so that's kind of a, so anyway.
Yeah. That's
I
that's I
digress.
think that's along the lines of that new model I think Meta put out, segment anything. So that I think that's right along the lines of that. I haven't gone too deep in the paper, but it's essentially what you're describing, a promptable segmentation type of uh, model. But yeah, segmentation, that's it's an interesting thing. Is I it Segmentation is this concept of things versus stuff, right? Stuff is just the amorphous stuff in the background, and things are this
Right.
group of pixels that are together that belong to a particular
Yeah.
thing. Yeah.